Algebra 2, 5-2, dividing polynomials. 5-2, dividing polynomials. So we're going to look at a couple different ways to divide polynomials today. We're going to start with kind of more like a factoring way of dividing polynomials. So we're going to start with an example. 6x to the fourth power y to the third power minus 12x to the third y squared minus 18x squared y over 3xy. So this first method here is just kind of a factoring kind of a method where I look at the denominator and I see in each of these terms what do I have in the denominator that is a factor of each of these terms. In order to factor any of these out, this has to be a factor in each of the terms. Okay, that doesn't make a whole lot of sense what I say, but let's work it out. So I notice in this here, I have 3 times 2 is 6. I've got x to the 4, x times x times x is x to the fourth, and I've got a y. Okay, so all of these can be divided out of this one. Let's look in this term. I've got 3 goes into 12 4 times, x goes into x to the third 3 times, or x times x times x, same thing with the y times y is y squared. Okay, so I've got all 3 of these guys are included in both of these terms and this third term as well. So here's what we do. I say, okay, so 3 can go into each of these, so I can cancel or simplify or whatever this 3 out of here. So 6 divided by 3 is 2. 12 divided by 3 is 4. Remember, there's a negative here. 18 divided by 3 is 6. So I'm going to cross those out because I have factored those. I'd simplified that. Remember that those negatives are there. X here goes here, here, and here. So x here, x to the fourth divided by x to the first, that's x to the fourth minus 1. So that is x to the third. So there I have x to the third. Here I have x squared. Here I have just x. Now let's do the y's. Y squared is what I'm going to get there. Just y there. And those y's both go away. And so now I just write out what I have left over here. 2x cubed y squared minus 4x squared y minus 6x. And since I've canceled everything out from the denominator, that all went into each of these terms, I don't have a denominator anymore. That's my, or my denominator is 1, right? That's my answer. Okay. Now, let's look at this next one. You guys are going to do this one. Just try to follow that same rule here. So, 20 c to the fourth d squared f minus 16 c d f f squared plus 4 c d f. And underneath here I've got 4 c d f. Okay, so see what you can cancel out here, what you can simplify, and we'll get back to it all together. Go. All right, so I've got 4 here in the denominator. 4 goes into each of these terms, so I can divide each of these by 4. If this was 3 here, I couldn't divide any of them by 4. They all have to be divisible by 4 in order for me to divide any of them. So 20 divided by 4 is 5. 16 divided by 4 is 4. 4 divided by 4 is 1. All right, C. I've got C's in all of these. All right, c to the fourth divided by c to the first power is c to the third power. D squared divided by d is just d. F divided by f is 1, so that f just goes away. F divided by f is 1. C divided by c is 1. D divided by d is 1. F squared divided by f is f. And then 4 divided by, we already did that. C divided by c is 1. D divided by d is 1. F divided by f is 1. So all of that goes to 1. All right, so I have divided each of these pieces into each of these terms. So let's write out what's left. I've got 5c cubed d minus 4f plus 1, 1, 1, 1. So it's just 1 times 1 times 1 times 1, which is just 1. That's an easy thing to forget, to put that plus 1 here, because 4cdf divided by 4cdf is 1. It's easy to kind of think, oh, that's 0, but it's not. It's 1, so you need that plus 1 there at the end. All right, long division. So here's the other method of dividing polynomials. And this is a division algorithm. All right, long division. So here's how this works. Here's an example. And I've got x squared plus 3x minus 4 divided by x minus 5. Okay, I want to divide this out. So here's how I do this. I write x minus 5 over here. And then I write my long division box here, x squared plus 3x minus 4. You thought you were done with long division a long time ago, but you are not, my friend. Here we go. Here's what I do. I look here and I look at what would make, what do I need to get from x to x squared? What do I multiply by x to get to x squared? X, right? And we're going to put that right here over the other x. So x times x squared. Okay. And then I multiply it. X times x is x squared. X times negative 5 is negative 5x. All right. Now, I need to subtract this from this. So I'm going to multiply this whole thing by negative 1, so I get negative x plus 5x. X squared minus x squared is 0. 3x plus 5x is 8x. Okay, now, what do I have to multiply by x to get to 8x? Positive 8, right? So I add 8. 8 times x is 8x. So let's do that again. 8 times x is 8x. 8 times negative 5 is negative 40, right? 40. Almost said 35. That was crazy. Okay. Now, oh, I forgot to bring this. Oh, I'm doing minus. Sorry, I messed up this equation. This should be 4. It should be minus 40. Sorry. One thing I forgot to do here, people, sorry, is to bring down that negative 40. What a mess. I should just do the video all over again. Nope, I'm not going to do that. So bring down that negative 40. Make sure it's negative 40, not minus 4. Goodness gracious. Now, I need to subtract again. So I'm going to multiply this whole thing by negative 1. And I get minus 8x plus 40. And that just is 0. And so that means I have no remainder. Yay. And if you get 0 at the end, so my answer is 8x. 8 plus x, gosh. Now, if I were to multiply 8 plus x, or x plus 8 times x minus 5, if I was to FOIL that out, I would end up with x squared plus 3x minus 40. So x squared plus 3x minus 40 divided by x minus 5 is x plus 8. Let's do another one. Let's try to write this problem down the right way this time. Okay, x squared plus 7x minus 30 divided by x minus 3. All right, let's do this one again together, and then I'm going to have you do a couple U-tries. All right, so I'm going to write x minus 3 here, x squared plus 7x minus 30. Double check to make sure I'm writing my... Good. I wrote the example down correctly this time. Okay, so now I think, what do I have to multiply by x to get x squared? It's just x. So same as the last one. Now I multiply. X times x is x squared. X times negative 3 is negative 3x. Multiply by negative 1, so I get negative and positive right there. So those go away to be 0. 7x plus 3x is 10x. Bring down the negative 30. Now what do I need to multiply by x to get to 10x? It's positive 10. 10 times x is 10x. 10 times negative 3 is negative 30. And so that is 0 when I subtract those, because I need to multiply by negative 1 so I can subtract those from each other. And so I get 0 down here at the bottom, just 1 0, not 2 zeros. Anyway, so I got no remainder, so that means this is my answer here, x plus 10. Okay, let's have you do one. X squared minus, where'd my eraser go? X squared minus 13x plus 12 divided by x minus 1. All right, so go ahead and do that problem, and let's get back together and see how you did. Pause and go. Okay, let's see how you did. X minus 1 and x squared minus 13x plus 12. Okay, so I'm going to say, what do I multiply by x to get to x squared? Put that right here. X times x is x squared. X times negative 1 is negative 1x. Multiply by negative 1. The x squareds go away. Negative 13x plus x is negative 12x. Bring down this 12 plus 12. What do I multiply by x to get to negative 12? I multiply by a negative 12. Negative 12 times x is negative 12x. Negative 12 times negative 1 is positive 12. Multiply this bottom row by negative because I want to subtract them. And so I end up with 0. Again, no remainder. X minus 12 is your answer. All right, let's do one that ends up with a remainder. Let's do one with a remainder. Let's do that. Let's actually do one more you try without a remainder. All right, you're not going to get a remainder if you do this one correctly. So let's just do one more because I know this is a new concept for most everybody. So x squared minus 2x minus 15 divided by x minus 5. So you shouldn't get a remainder on this one. Go ahead and do this other you try. Pause and go now. All right, let's see how you did. X minus 5. X squared minus 2x minus 15. All right, what do I multiply by this to get to this? It is an x. X times x is x squared. X times negative 5 is negative 5x. Multiply by negative 1, and I get 3x here. Bring down the 15. And I now have, I need to multiply this by 3 in order to get 3x. So I'm going to add 3. 3 times x, 3x. 3 times negative 5, negative 15. Multiply by negative 1. Switch these signs. I end up with 0. And so x plus 3 is my answer for that you try. Now let's do one together with a remainder. Let's do it here. Example, a squared plus 7a minus 11 times 3 minus a to the negative 1 power. So remember what the negative 1 power means. That just means that this is 1 over 3 minus a. That negative 1 says put me onto the other side of the fraction bar. Now we have another problem, and that is that I have 3 minus a. So that means I'm going to have to put negative a plus 3 as my binomial here. So I want the a to be on the left and the 3 to be on the right. This is a negative a, positive 3, negative a, positive 3. All right, now we can do this. X plus a squared plus 7a minus 11. All right, what do I multiply by negative a, or what do I multiply by negative a to get positive a squared? I need to multiply by negative a, right? Negative a times negative a is positive a squared. Negative a times 3 is negative 3a. Now I need to multiply by negative 1, so I get negative, positive there. Those go away. I have 10a. Bring down my negative 11. What do I multiply by negative a to get positive 10a? I multiply negative 10 by that. Negative 10 times negative a, positive 10a. Negative 10 times 3 is negative 30. Need to multiply by negative 1, negative, positive. Those go away, or become 0. Negative 11 plus 30 is 19. And so that's my remainder. And so my answer is this, negative a plus 10, minus 10 plus 19 over 3 minus a. So just like back in long division days, when you would take the this number over here that we put on the left, and we'd put that underneath the denominator and put the remainder on top of that, we do that same thing here with polynomials. So that's how we do a remainder. We'll see more of those later. I think, yeah, we will a little bit. Okay, so that's long division. Now we're going to look at synthetic division, and this is the last type of division that we're going to look at in this section. Synthetic division. This is kind of actually a little bit fun, I think. Example, 2x cubed minus 13x squared plus 26x minus 24 divided by x minus 4. All right, so here's what we do. We draw a little box over here, and we draw a line over here. And what we put in this box right here is whatever makes this 0. So whatever makes this guy 0, we put in the box. So it would be 4. If whatever you would put in for x to make this guy 0, I should say, right? 4 minus 4 is 0. So that's what goes in that box. Now we write each of these guys up here, just the coefficients, just the number that's out in front of the variable. So 2, negative 13, 26, negative 24. Now we're going to make sure this says x to the third, x squared, x to the first, and then no x. If we're missing any of these, so if it was x to the third and then skipped x squared and went straight to x, we have to put a 0 place marker where x squared should be. We'll see that again later as well. Okay, now here's what we do. We take this 2, we put it down here. Bop. 4 times 2 is 8. Negative 3 plus 8 is negative 5. 4 times negative 5 is negative 20. Negative 20 and positive 26 is positive 6. 4 times 6 is 24. Negative 24 and positive 24 is 0. So when you get 0 here, that means you have no remainder. And here's what we do with your answer. Or here is the answer to this question here, this division problem. 2x squared minus 5x plus 6 is your answer. So we had x cubed here, we divided by x, and so we end up with x squared, x, and then there's no x there, just the constant. All right, let's do another one. 2x cubed plus 3x squared minus 4x plus 15 times x plus 3 to the negative 1. So remember, this just means all of this divided by this, because this just goes as the denominator. So don't let that scare you, but it's good we're seeing it. So what value for x makes this binomial 0? It's negative 3. Put that in a box. Draw a line. We write 2, 3, negative 4, positive 15. We bring this 2 down. 2 times negative 3 is negative 6, which gives me negative 3. Negative 3 times negative 3 is positive 9, which gives me 5. 5 times negative 3 is negative 15, and I get 0 here for my answer, so I have got, again, no remainder. Yay. And now I need to write this depressed polynomial, is what it's called. 2x, since this was cubed, this one's going to be squared now, minus 3x plus 5 is my answer. Okay, let's do another one. Let's have you do one on your own. You've got, I think, 3 examples left here to do. So 3x cubed minus 8x squared plus 11x minus 14 divided by x minus 2. All right, see if you can do this one on your own. And then, yeah, we'll check it out together. Go. All right, let's see how you did. X minus 2. Oops, not x minus. I was just about to do long division on this thing. What makes this 0? What x value makes that 0? It is positive 2. Then I say 3, negative 8, positive 11, negative 14. Put that over this bar here. I can draw this too here if I want. All right, 3 comes down. 3 times 2 is 6. 6 and negative 8 is negative 2. 2 times negative 2 is negative 4. 11 and negative 4 is 7. 7 times 2 is 14. Negative 14 and positive 14 are 0. Now my answer is 3x squared minus 2x plus 7. Hopefully you did that one well. Let's do one more. This one is going to be a you try as well, but I'm going to give you a little help with it. So I've got 6x cubed plus 5x squared plus 9 over 2x plus 3. All right, this one is a complicated one. Maybe it's not a you try. This has 2 special things happening in it that we haven't looked at yet. So the first thing is, notice how it goes x to the third, x squared, and there's no just x. The other thing is this is over 2x plus 3. Hopefully that's not an issue. That just means this numerator divided by this denominator. So it's the same thing we've been looking at it, just written out in a different way. The other thing is we've got 2x plus 3, and we've got to decide what this x is. That's going to be a fraction. So let's just do this one together. We'll just say this is an example. This is kind of a messy one. It's all right though. So what makes 2x plus 3 0? What do I plug in for x to make this 0? It's negative 3/2. And if I'm not sure about that, just go like this. 2x plus 3 equals 0. I want that to be 0, so I say subtract 3. 2x equals negative 3, divide by 2, divide by 2. X equals negative 3/2. All right, so negative 3/2 is what the x value that makes this binomial 0. So now I write down these numbers here, 6, 5, and then I don't have an x represented here, so I need to put a 0 as a placeholder. And then I have 9. All right, this is important. Don't miss that. Here we go. Bring the 6 down. Negative 2/3 times 6. So if I don't have that ready in my mind, negative 3/2 times 6, that's 18 divided by 2. So that's negative 9. All right, 5 plus negative 9 is negative 4. All right, negative 4, I'm not sure what that is either. Negative 2/3 times negative 4 over 1. 4 times 3 is 12. 12 divided by 2 is 6. Negative times a negative is a positive. Positive 6. 0 and 6 is 6. Now, negative 2/3 of 6, I've already done that one, right? So negative 2/3 times 6 is negative 9. So negative 9, 0. Whew, no remainder. That's awesome. Now I need to just rewrite this in this form here. So I've got 6x squared. Remember, we start with third. So now we're step down to squared, minus 4x plus 6. There's my answer. Now, there's a better form of this answer. And that is, notice how each of these numbers can be divided by 2. Notice how this thing here is 2 in the denominator. Coincidence? I think not. But let's just divide this whole thing by 2 and we get the better answer. So it should be 3x squared minus 2x plus 3. Now, so this is the better answer here. Now, there's another way to do this that the book talks about, and I don't like it as much. I like this way better, to keep it a little bit more simple. So there is another method that is shown in the book that I've shown in the past that's very similar to this, but it makes it a little bit more complicated. So I'm just going to show you this method. We're going to do one more. Actually, you are going to do one more. And this one is 3. So last example, this is a you try. 3x to the 4th minus 5x cubed plus x squared plus 7x. Notice there's nothing here. There's no 0. There's no number here. So what do you do about that? Divided by 3x plus 1. Okay. The book divides this whole thing by 1/3. And then they do this whole thing that way. I recommend doing it my way because it's just a little bit cleaner. But, you know, do it however you want. Go. All right, let's see how you did. So this should be negative 1/3 to make this whole thing to be 0. So negative 1/3. Put that in the box. 3, negative 5, 1, this should be 1, 7, and then 0. All right, bring my 3 down. Negative 1/3 of 3 is negative 1, get negative 6. Negative 1/3 of negative 6 is positive 2, so that'll give me 3. And then negative 1/3 of 3 is negative 1, that'll give me positive 6. Negative 1/3 of 6 is negative 2, so I have a remainder of negative 2. Bummer. It's okay. So now I've got 3x cubed, because the last one was to the 4th, minus 6x squared plus 3x plus